This is an introduction to the Public Land Survey System. And that's the name of the system in the United States and most states, which allows us to geographically locate parcels of land on the surface of the earth. And as you can probably imagine, this is really critical for natural resource management because everything that we do in natural resources has a spatial component to it. Now, this looks a lot like a coordinate system, but it differs subtly from a coordinate system in that a coordinate system usually locates points on a grid, whereas this system is designed to locate parcels, two-dimensional spaces on a grid. The Public Land Survey System was initiated by the Articles of Confederation, which preceded the U.S. Constitution. So in 1785, that stipulated that there should be a rectangular survey of federally owned lands. So that federal rectangular system was set up, but because it was set up, after the 13 original colonies and then states already were inhabited, it doesn't really cover those. In addition, it doesn't cover the states of Maine, Vermont, West Virginia, Kentucky, Tennessee, Texas, and Hawaii. Another note is that Ohio was the first state out west, in this system, and it included several experimental systems, so there's some variation in Ohio. So this is the states that are included in the Public Land Survey System, most of them. But as I mentioned before, there's several states that are not included in the system. At this point, most of these states do have, some type of survey system set up, so you can locate properties and put them on deeds and so on, but they're going to be a little bit different than this standard that exists in the other states indicated in blue. So the starting point for this rectangular survey starts with a principal meridian, which is a line that goes perfectly north-south. And those principal meridians then cross a perfectly east-west line called a baseline. The point at which those two lines intersect is the initial point, or the point of beginning. These initial points and principal meridians all have names. The one in Florida, which was established in 1824, is called the Tallahassee Meridian. And as you might expect, it runs through the city of Tallahassee. And if you go to Tallahassee, you can actually find the initial point for the Tallahassee Meridian in a park in Tallahassee. So this is really cool. If you go to Cascades Park, you can find a brass plaque which indicates the initial point, and it's set in this neat granite map of the state of Florida. So that's a pretty neat monument to the Public Land Survey System in Florida. So this map shows the principal meridians for a number of different units. So for Florida, this is the Tallahassee Meridian and the initial point in Tallahassee, of course. In some cases, for instance, this yellow group of states, one principal meridian, and this one's called the sixth principal meridian, covers a number of states. Whereas in other cases, a principal meridian just covers part of a state, due to various reasons. But at any rate, this shows the different principal meridians, which essentially indicate one large survey unit. So this is a zoom in on Ohio. Why does Ohio look so weird and have so many different principal meridians and units? Well, because like I mentioned before, Ohio was experimental and had a number of different system types used in its survey before they settled on this standard that we're talking about now. So now we've got this principal meridian and a baseline with the initial point at their intersection. When these surveys were established, and I want to interject here just to remind you that most of these surveys occurred in the 1800s or early 1900s by field crews, living in the wild and doing these surveys with staff compasses and metal chains. So it's really a remarkable technological achievement that these survey crews with very primitive tools were able to lay out the survey system for an entire nation to actually a very high degree of accuracy. It really is quite an accomplishment. So I don't want us to forget that. At any rate, so we've got the initial point here. The next thing the survey crews did was travel 24 miles north and establish another east-west line. And those east-west lines, every 24 miles, are called standard parallels or township lines. So those are lines that run due east-west, every 24 miles going north or south of the baseline. So that's the start of building that grid. So the next task then is, again, starting from the initial point, for instance, shown here, to travel east along the baseline 24 miles and then establish a due north line going north from that baseline, which is called a guide meridian or a range line. So that's the first guide meridian east, the second guide meridian east, another 24 miles, and the third guide meridian east, another 24 miles. All these lines go due north-south. So once those are laid out, one thing to note is that this distance along the baseline here, for instance, is exactly 24 miles. Whereas this distance along the first standard parallel, north, is a little bit less than 24 miles. And that's because on the globe, perfectly north-south lines are not parallel. They all converge at the North Pole, of course, or the South Pole. So as you go further north, they get closer together. And that's why they only go 24 miles north, is so that they minimize that error that occurs. So this error, the fact these lines are less than 24 miles apart, is actually pretty small. So once they get to then this first standard parallel, they start over again and then go another 24 miles and then go due north. And that allows them to minimize that effect of the non-parallel guide meridians. Okay, so that's an interesting point that's due to the spherical surface of the Earth. Oh, I've already answered my question. The guide meridians are not parallel because they run due north-south, converge at the North Pole, and therefore get closer and closer to each other as you go north. Okay, so now we have these lines laid out basically every 24 miles. You've got this square that's basically 24 miles square. If we blow that up, this first set of squares, they then subsidize that 24 mile by 24 mile square into units called townships that are each 6 miles by 6 miles. Okay? So each of these squares is 6 miles by 6 miles, which gives you 24 by 24. And then these are numbered. So each township is numbered relative to the initial point. So this first township is the first township north of the baseline. So it's township 1 north, and it's the first township east of the guide meridian. So it's range 1 east. So this township is referred to as township 1 north, range 1 east. The next one to the east is township 1 north, range 2 east, and so on. So for instance, this one is township 4 north, 1, 2, 3, 4, and range 3 east, 1, 2, 3. Okay, so that's how those townships are named. All right, so now we've got townships, and if we blow a township up, remember a township is 6 miles by 6 miles, that township is then subdivided into 1 mile by 1 mile squares. Each of these 1 mile by 1 mile squares is called a section. And a section has 640 acres in it. So a square mile is 640 acres. These sections are numbered in a special way. So they all start in the northeast corner of the township and then are numbered in a serpentine fashion like this. So presumably they laid these out and just surveyed their way along in a serpentine fashion until they get to 36th in the southeast corner. So all townships have their sections numbered in this manner. Okay, so now the legal description, for instance, of this section is Section 32, Township 1 North, Range 4 East. That's the legal description of this section. Okay, so now when we get down to the level of a section, we're going to blow another section up, blow another parcel up. So now this is a 1 mile by 1 mile section. So subsections, subdivisions within a section are basically labeled as fractions and directions. So for instance, if we divide that section into fourths, each of these fourths is called a quarter. Okay, so for instance, this parcel is the northeast quarter of Section 24, Township 3 North, Range 4 West, if that's the township that this is in. Okay, now each of these quarters, is 160 acres. That's just 640 acres divided by 4. A lot of homesteads were 160 acres. So a lot of the homesteads parceled out by the federal government to settlers were a quarter section, 160 acres. And very often, either the farmer or when they sold them, they would sometimes, cut those quarter sections into additional quarters. So when that was done, those are quarter sections. Okay, so if you cut a quarter section into fourths, you now have 40-acre parcels. So for instance, this parcel right here, its legal description would be the northwest quarter, that's this, of the southeast quarter of Section 24, Township 3 North, Range 4 West. Okay, that's the legal description of this parcel. Let's say this one. This one isn't subdivided in fourths. This quarter section was subdivided into halves. So the legal description of this parcel is the east half of the southwest quarter of Section 24, Township 3 North, Range 4 West. Okay? This all, makes sense, but you have to sort of think about it and think about the fact that all legal descriptions start with the description of the smallest parcel and then going out from there and ending with the description of the township, basically. Okay? It's important to remember that in a survey, nothing's perfect. So I've been showing you a bunch of perfectly square parcels, for instance, that are exactly, a mile on each side, for instance. But, both due to the shape of the earth and other issues, these things are not always perfect. So for instance, I've already mentioned, since guide meridians and range lines are not parallel, townships and sometimes sections toward the north end of the standard parallels may be slightly compressed. So for instance, a township up here may be slightly less than 6 miles wide. And a section inside there may be slightly less than 640 acres. Another point is that if you were looking at a map of sections along this line, those will tend to be offset right here, because basically the point where those lower 24 mile by 24 mile subdivision stopped is offset from where the next 24-mile offset will be. Actually, I think this would be the other direction. I guess it depends on where the North Pole is relative to this. At any rate, there's usually an offset in where the sections lie along these standard parallels. And that's just because they basically reset every 24 miles. And then the final point I want to make is that, you know, again, these surveyors were out in the woods, in the wilderness, doing this work with analog tools, and sometimes there were errors, either due to inaccuracies of the tools or due to mistakes. And sometimes those, when they corrected those mistakes, they basically folded all the error into, you know, a section in the corner of a township. So sometimes you'll run into sections that are not square and not a perfect mile. They might be rectangular or have a little notch out of them or be some other strange shape. And that's sometimes because that section is basically holding the accumulated error that was accumulated somewhere else. Those are some of the things that you will run across when you're looking at, for instance, survey maps. But it's part of the charm as well, of course, right? So, you know, sometimes you just got to memorize stuff. And I would say it will serve you well to just memorize all the things on this slide, because you're going to be using these for the rest of your career. You know, the other thing to remember is that this is the English system, and because the United States was surveyed in the English system, even if we were to change to the metric system, our surveys will probably, you know, for a long time still be in English. So you're going to have to know these English measurements. So as natural resources folks, we often have to have 1 foot in English and 1 foot in metric, because sometimes we're speaking to scientists, sometimes we're speaking to landowners or practitioners who typically work in English. At any rate, so some of the measurements you really just need to know. One chain. A chain is actually a surveyor's instrument. It's a metal chain that was used to measure distance, and that is 66 feet. 66 feet, that seems very arbitrary, and by itself it is arbitrary. But there's method to this madness in that, for instance, 80 chains is exactly 1 mile. Okay, so 80 times 66 is 5,280 feet, which is 1 mile. Okay, so that's a nice even unit. Another way that chains works out is that 10 square chains, so if each of these boxes is 1 chain on a side, 10 of those is 1 acre. Okay, so 10 square chains is 1 acre. Not 10 chains squared, which is this, which would be quite a bit bigger. It's this. That's 1 acre. You just need to memorize that 1 acre is 43,560 square feet. Why would you want to know that? Well, let's say you're out in the field and you know you need to establish a 100th acre plot. Well, how big is a 100th acre plot? Well, if you have memorized that an acre is 43,560 square feet, you will know that a 100th acre plot is, move the decimal place over 2 places, 435.6 square feet is how big your 100th acre plot would be. And then you can then use pi r squared to solve for what the radius of a circle would be with an area of this. Okay? We already mentioned 1 section. You need to know that's, you know, 1 mile on each side. It contains 640 acres. It's also useful to remember that a quarter section is 40 acres. You know, Cletus is out plowing the back 40. When a farmer says that, they mean, you know, the quarter section of their 160 acre homestead. So that's the quick and dirty summary of the public land survey system, and may it serve you well.